Mike Pastor here again. Let's move on and talk about measures of position. So the first term I want to talk about is the standard score, or the z-score. And essentially what it is a measurement of the value of a data point with respect to the mean, and how many standard deviations it is from the mean. So the value, we take the difference between the value of some data point and the mean, and we just divide it by the standard deviation. Putting it in terms, symbolic terms. So some data point x minus x bar divided by s gives you the z-score. Of course, this is for a sample. You could also look at it in terms of x minus mu population parameters divided by sigma. Same thing though. Most often this is used for samples though. So for example, let's just say, let's swap over a new color here. Let's say that our data point x equals 38. And in this data set, we have a mean equal to 43 and a standard deviation equal to 4. Then, simply put, our z-score is just 38 minus 43 divided by 4, which equals minus 1.25. So, from this, we can determine that the data point is 1.25 standard deviations to the left, because this is a minus sign, to the left of the mean, or below the mean, you could possibly say. So that's our first item I'm going to talk about. Let's look over here. I've got a dot plot set up because I want to talk about percentiles. Another positional indicator. And this dot plot, let's just say it represents test scores. This is something everybody can relate to. Test scores. So one person scored a 10, two people scored a 30, three people scored a 45, two people scored 60, 168, and 190. So a percentile represents the percent of scores below the particular score you're looking at. So for example, say that you got a 68%. 68%. What percentile do you fall in? So the percentage that you got on the test is not quite the same as the percentile. So the percentile is, and there's multiple ways of calculating this, and I'm just going to kind of point out the two main ways. But the percentile of your score is the percent of scores that are in the first sense, let's say, well, it's the percent of scores that are at or below. But often people just represent this as the percent of scores below. So in the first sense, if your score is 68, what percent are below? Well, 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of a total of 10 equals 0.8. So you're in the 80th percentile. Okay, that's one way of looking at it. Another way, sometimes the calculation is done, it's less than or equal, whereas this was less than. Put a colon here so you don't think that I'm making an equation there. This is less, if we talk less than or equal, then you have to actually count your point too. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 9 and 10, which is 0.9, which is a little different. Now you're in the 90th percentile. So these are the two most common ways of calculating this. Now your book actually calculates the percentile even different, slightly different. And if you look in your book and you apply this data, I think you're going to end up in the 85th percentile. But it's just an idea of where your data point lands in the data. Don't get overly concerned with the specifics of calculating it. Just understand that what it typically means is if you're in the 80th percentile, then 80% of the people scored below you, or potentially, if you're calculating it with less than or equal, 90% of the people scored the same or less than you. Now, why is this useful? Well, what we can do is we can play around with percentiles. One of the main ideas, one way of representing data is with percentiles. And you probably hear it a lot when they're talking about test scores, like your SAT test score. You might have scored something. You might have scored some score on the SAT, but you see next to it, it says what percentile you're in. And that tells you it gives you an indication of how well you did compared to everybody else. Well, quartiles are the percentiles at certain points. And they're often represented with these Qs. Q1, Q2, and Q3 are three main important ones. Q1 is often represented as the 25th percentile. I don't want to write percent there, actually. Don't want to think it's a percentage. 25th percentile. Q2 is the 50th percentile, but it's also the median of the data. And Q3 is the 75th percentile. I'm running out of time. I'm going to have to make another video to discuss this. So I will get back in touch with you in a second.